Welcome back. In this video, we're going to continue with Chapter 1. So this is the second part of Chapter 1. We're going to keep going over isometric views and orthographic projections. So quick summary from our last class session. Once again, let's look at Jack. So this is the isometric view for Jack. How do we define the front view? So we have Jack's mugshot. So imagine you're standing facing Jack, looking dead in the eyes, and you get the front view. Again, typically the front view, as I mentioned before, is the view that gives you the most information, the most data. Okay, so now you're going to walk around Jack to the right side, and you're going to look directly. If he had an ear, you'd be looking straight into his ear, and you would get this right side view. Even though we're looking at the left side of Jack's face, this is considered the right side view. Okay, let's go back and face Jack. So we're going back to the isometric view, face Jack. And now you're going to fly over the top and look straight down, and you're going to get the top view. Okay, so we have our front view, our reference view, and our orthographic projections. Horizontal and vertical orthographic projections, and we have our isometric view. All right, so always refer back to Jack's mugshot if you're having trouble visualizing orthographic projections, and also using the isometric view to help you create them. And there's more examples, as you can see. And again, I mentioned before, typically your front view, you want it to be set up. First of all, it's the view with the most information. And also you want to set it up so it goes a long way horizontally. Here the calculator, instead of going horizontally, it's going vertical because it makes more sense to look at a calculator as we do vertically, the vertical position, versus laying down horizontally. Okay, so this is an exception to the rule. We're still looking at the front of the calculator, but we're standing it up vertically because that's the way we use it. All right, so another way of looking at third angle again, as we learned in our last class session, is third angle projection. It's the same as attaching a jack to a tether pole, right? With a chain or rope, and you're standing on the opposite side of the pole. You get the front view. If you rotate 90 degrees horizontally, you get the right side view. And if it keeps going another 90 degrees, then you see the back of Jack's head and so on. Okay, so once again, good way to look at third angle projection. And that's what we're going to be using throughout the class. And here we have first angle projection again, except we don't use first angle projection in this class. Okay, and it's to avoid confusion. Okay, so we're not going to use first angle projection. And in this case, you would attach the rope or the chain to the back of Jack's head. And you would get these views instead if you use first angle projection. And again, there's nothing wrong with first angle projection. It's just like we like to drive on the left side of the road. Other countries like to drive on the right side of the road. It's just a matter of preference and what they're used to. So neither way it's wrong, except here in America, we prefer to drive on the left side of the road, and we prefer third angle projection. Okay? But just be aware that there are drawings drawn in first angle projection, especially in European and Asian countries, and I think also South American countries. Okay, so once again, third angle projection, the glass box, you project the views to each wall. You open up the box, right? The glass box, if you could open it in third angle projection. And these are the views that it would generate. Again, third angle projection. That's all we're using in this class. And once again, just to emphasize, when you see dashed lines, if you're standing on the rear view of this part, you will not be able to see this surface or this edge, nor the slot. If we go back, here's that edge I'm referring to, and the slot or this partial slot. So if you're standing behind the glass box, again, you cannot see the edge nor the slot. That's what we're getting here. So imagine you turn on your X-ray vision and you're able to see through iron, through steel, right? And you would be able to see the edge and the slot. And we represent it with dashed lines. So these are hidden features that we cannot see, but we do know that they are there. Okay, so we're going to keep working on orthographic projections. We're not going to draw any more isometric views for the rest of the class, but later on I will provide some extra credit for those of you that want to draw isometric views using AutoCAD. Because of time and the wealth of material we're covering, we don't have time to a lot of time to spend on isometric views, but I will provide an extra credit assignment later on for those of you that feel the need to practice or just want to learn how to create isometric views in AutoCAD. And by the way, in our next class session, we will be jumping in on AutoCAD. So I know some of you want to jump on AutoCAD as soon as possible. That'll be our next class session. All right, so today we're going to be practicing more orthographic projections. So using the isometric view, we're going to define our front view, right? You stand in front of the building. Here's our front view. We're going to go off to the side, right side view. And here it is, our right side view. And once again, the dashed lines represent the whole. And I want you to notice that everything lines up. Again, I mentioned this in the previous lecture, but I want to emphasize it. The top view, right? The top lines up with the top here. The bottom lines up with the bottom, and so on. We have this edge, right? This line here, this edge lines up with this one. And the top quadrant and lower quadrant of the whole lines up with the dashed lines, right? So these dashed lines represent the whole going through all the way from the front through and out the back. Same thing at the top. We have these dashed lines representing the whole. So we go to the left quadrant, right quadrant of the whole, and go straight up, and everything lines up. This left edge lines up with this left edge. This edge here, right? This top edge lines up with this vertex, and so on, okay? So it's very important that you keep all three views in line with each other. One of the rookie mistakes I see with students or even interns, their views are not lined up. They'll have the right side view floating out here in space somewhere or down here, but everything needs to line up. It's important that all three views line up. That's what they're called. That's the reason they're called orthographic projections. If it's not lined up, something's wrong. All right, so let's take a look at your next assignment. Okay, so here's the first page of 4. So I'm going to provide you with the handout. It'll be 4 pages, 4 problems per page for a total of 16 problems. So on this handout, you are to sketch the 3 views. You can freehand it. You can use a straight edge, a triangle, a ruler. It doesn't have to be straight lines. It's okay if you don't have a straight edge to work with. I'm going to grade you on completeness and not on how straight your lines are. All right, so the first problem is done for you. So again, think of Jack's mugshot. Here's the isometric view. Stand in front of the building, look straight at it, and this is the front view. Go around, and we get this right side view. Come back to the front. You always have to come back to the front. And now we float to the top, look straight down like you're flying over it, and this is the top view. Okay, so you are to create all 3 views for each problem. Again, there's a total of 16 problems. The first one's already done for you, and this is a handout. It's worth 25 points. So were the 2 previous handouts, handout 1A, 25 points, and handout 1B, also 25 points. If you don't get a perfect score on your handout, you are allowed to resubmit a second time to improve your score. Also, there are no due dates, right? Some of you are already turning in your assignments as you go. So soon you'll get them graded. And if you didn't get a perfect score, once again, you can resubmit second time to get that perfect score. And again, if you want to wait till the end of the semester to turn in all your work, you may. Just a reminder, it's going to be a lot of work. So don't fall behind. It's better if you turn it in as you go, but again, no due dates. All right, so I'm also going to provide you with the answer key so you can check your work. So try and create the 3 views on your own. If you make a mistake, if you're using pen and you make a mistake, it's okay if you scribble your mistake out. Okay, so you can use a pencil or mechanical pencil or a pen or marker. If you make a mistake, just scribble it out, scribble over it, and I'll know it's a correction. All right, so I will provide you with the answer key. Again, there's 16 problems. So you can check your work, try and see if you can figure it out on your own first. All right, another thing I am going to provide. Let's go back to the lecture. I am going to provide you with 3D models. Now, the 3D models, it's not part of the assignment, but I decided to create 3D models for those of you that are having trouble visualizing the front view and orthographic projections, right side view and top view. Okay, so I'm going to provide you with 3D models that you can open up in eDrawings. And the 3D model, you can rotate it. You can ask for the front view, side view, bottom view, and so on. And it'll orient in itself. It'll rotate itself and give you the front view, side view, top view, left side view, bottom view, etc. For this handout, we're only going to be doing a front, top, and side view. Okay, so I will create a second video on how to use eDrawings. So again, eDrawings is a free software. It's called a viewer. It's just to view 3D models or to view 2D drawings. Again, eDrawing software is not something that we're covering in this class, but it is available. So those of you that are coming to campus using the computer lab, we do have eDrawings. Just look for this E symbol, eDrawings. Again, it's a free viewer software. And again, in a second video, I'm going to show you how to download it. If you want to download eDrawings on your personal computer, there's a Mac version and Windows version. Some students have told me that they've had issues opening the software on their Macs. I don't know if eDrawings has fixed that. But again, this is optional. So those of you that are having trouble visualizing the 3D models, or my mistake, the orthographic projections, front view, side view, top view, then in the second video, I'll show you how to download eDrawings and how to open up the file. So I will provide you a zipped folder, a compressed folder with all 16 problems, all 16 3D models. And I'll show you how to unzip it and how to open them. Again, these are compressed files. And when I email it to you and also place it on Canvas, just so it doesn't eat up a lot of memory, I end up compressing it. It's called a zip folder. So it eats up less memory when I email it or place it on Canvas. All right, so talk to you in the next video.